So hello everyone, welcome back to another video or another lecture series of our organic spectroscopy. And in the previous class, we are actually talking about the basics of the electromagnetic radiation and basic understanding of the spectroscopy. Now here actually we are entering our main topic. It is the IR spectroscopy. So today in this particular video, we'll initially talk about the basics IR spectroscopy and the mode of vibration. So this is a smaller lecture. Okay. So first let us talk about the IR spectroscopy. As I already discussed in our previous lecture, that IR spectroscopy is arise due to the interaction of molecule while irradiate the molecule by using an infrared radiation, or you can say the infrared region electromagnetic radiation. And due to this particular infrared radiation in particular the molecule getting vibrated, like there is a no possibility of electronic transition, they will show vibration, and depending upon the vibration is actually understand depending upon the vibration they are actually show the empirical analysis of the particular molecule. And since it is associated with vibration, then it is called a vibrational spectroscopy. So what is the range of IR spectroscopy? Range of IR spectroscopy in 400 to 4000 centimeter inverse, and this is actually given in the wave number form. Okay, wave number, and it is associated with nu bar. Okay, so here you can see that this particular are the range of IR, where 50 centimeter inverse to 50 centimeter inverse is the far IR region, that is not important for the organic spectroscopy point of view. Now 450 centimeter inverse to 1500 centimeter inverse, this is all are actually wave numbers. Please be cautious about that. Okay. This is actually called as the fingerprint region, and fingerprint region have their own significance. We will discuss later, not right now. And the 1500 centimeter inverse to 4000 centimeter inverse, it is actually the functional group region. Like different functional group peaks are actually observed here. And after that 4000 to 12500 centimeters is the near IR region, that is also not necessarily important for the IR spectroscopy point of view. So the main important or more actually the highlighting point for the IR spectroscopy range is the 450 centimeter inverse to 4000 centimeter inverse. And usually if you see any kind of IR spectrum, then you can see that all the range are actually determined between 400 centimeter to 4000 centimeter. This is the most important part. So there is the associated some selection rule there for any molecule to be IR active molecule or show the IR spectroscopy. So the first rule is molecule have a permanent dipole moment are IR active. Okay, so this is the most important rule. And also if the molecule have no permanent dipole moment, but during vibrations it will change, alter or develop a temporary dipole moment, or we can say the dynamic dipole moment, then the molecule is also an IR active molecule. And the very important is homonuclear diatomic molecule, that means H2N2, this type of homonuclear diatomic molecule are never IR active. And heteronuclear diatomic molecule are always IR active, because heteronuclear diatomic molecule always have any kind of permanent dipole, and since they are always IR active. Example, H2N2 are not IR active, but HClNO, these are the heteronuclear diatomic, these are IR active molecule. Okay, now let us talk about the mode of vibration. Like as we discussed about there is a different type of vibration observed due to the interaction of the matter or the molecule by the IR spectrum. So there is a two type of actually vibration is observed. One is the stretching vibration, one is the bending vibration. On the stretching vibration, there is a two type of stretching, on the symmetric stretching and asymmetric stretching. Like here you can see this particular OH group. Now, upon irradiating this particular with the infrared light, what happened that either these bonds are both are simultaneously elongated or simultaneously squeezed. So this type of motion is called symmetric stretching. Antisymmetric stretching suggests that one between two different bond, one is stretch, one is squeeze, and then it will squeeze, it will stretch. So there is the asymmetric stretching is observed, then it is called asymmetric stretching. And bending mode, bending is a two type of bending. One is the in plane bending, like this is a molecule. If the molecule has bent like this, it is called scissoring. This is the in plane. There is a no plane change. And twisting and working means this type of rotation has been observed, or we can say that bending is observed where the molecule get go out of plane. Like this is, if it is in plane, this molecule is go above to the observer and this part is go to below to the observer. Similarly, this type of rotation, now this go to the above to the observer or near to the observer, and this particular molecule is go below to the observer. So this is called the out of plane motion. So we'll learn this in an animation, first checking this particular thing, mode of vibration. Like this is the symmetric stretch, like both are simultaneously elongated and squeezed. Asymmetric stretching, one is elongated, one is squeezed, and vice versa. And bending, as I already discussed, that these two comes here and come back. Rocking suggests that both are goes like this. Like if we see over the pendulum motion, go there and then come back. In the both case, this is called the rocking. And wagging and twisting is the wagging suggests that if your molecule something like this, both are goes like this, then come back, then come there. This is called wagging. And twisting is one goes there and one goes out of the near to the observer, and one goes to the away to the observer. And wagging, both are going simultaneously near to the observer and uh, away to the observer. Okay, so let us know this particular simple animation. Like here you can see that this is a symmetric stretching, both are elongated and both are squeezed. Asymmetric, one is elongated and at the same time one is getting squeezed. Scissoring, as I already discussed. Rocking, wagging, both are come, once it is come near to the observer, both the, and then one getting the away to the observer. And the twisting is one in the same time frame, one is away to the observer and one is the near to the observer. So I hope with this particular animation it will be very much crystal clear for you to know the mode of vibrations. So with this we have to end this particular lecture. So in the next lecture we are talking about the physical interpretation of IR. There are little bit of quantum mechanics is there, but very minutely, not any kind of mathematics. And we're talking about the Hooke's law and different fundamental bands in IRs. So thank you for listening.